Hello, my ninja warriors. What's up, everybody? So, today marks the last day of the day 5 challenge, and we are going to start relations and functions. Okay, mathematics first today, and physics will be last today. So, you have started with physics. Okay, this 5-day challenge, and you will end with physics to physics journey. Okay, meanwhile in between chemistry and maths are sandwiched between physics sessions. Okay, all right, now we have reached till 4th November. Tomorrow will be the reveal of high weightage crash course, that is sigma crash course, tomorrow at 5 o'clock. All right, okay, yes. So one student is writing, not even a single chapter you did completely. JEE main level, come on, JEE main level. We are solving JEE main PYQ, and that to 12 to 13 PYQ in 1 hour. What are you talking about, Piyush Mishra? I think that you were actually texting some other channel and you forgot the way and you are texting over here. I am very confident about these sessions. Okay. So don't you dare write random things over here. We are very professional and we know JEE main. See our experience over here. Can you see I am teaching since more than 10 years. Okay. So I exactly know what kind of questions JEE main is going to ask, unless NTA decide that okay, I am going to ask something JEE advanced level. Okay, so here we are actually always teaching one level up from JEE main, right, Piyush Mishra? Okay, so let's start. What a beginning of day 5. Thank you, Piyush Mishra. But anyway, yes, so this is my brief introduction. My name is Namrata and I have over a decade of teaching experience in both online and offline. I have been teaching for mathematics, for JEE main, and you know what? I have been predicting that what kind of questions JEE main is going to ask every year. And you know what? A lot of, like, majority of my prediction is true, and the prediction is not an astrological prediction. Let me tell you, it is a deep research which we conduct of previous 7 to 8 years. Okay, yes, all right, perfecto. Okay, let's start today's session. So relations and functions. Now one short question you will see in JEE main 2026 from relations. Okay, that question, now let me tell you that 3 category questions are observed if I talk about relations. Okay, so category number 1 is this category, right, which will just ask you that equivalence relation, which will ask you about symmetric, reflexive and transitive. Okay, all right, yes. So define a relation R on the interval 0 to pi. Okay, if this relation is satisfied by your ordered pair, then your R is what? Okay, all right, let me tell you what I'm trying to say over here. See, this whole question is telling you that x comma y will sit inside relation R if and only if sec square x minus tan square y is equals to 1. Now tell me whether this relation is reflexive, symmetric or transitive. Let me write down the definition, right? Reflexive over here. So reflexive relation is what? Reflexive relation means that both the elements of the ordered pair should be same. That means we need to check whether x comma x is sitting inside my relation R or not. That's what we need to check. So here sec square x minus sec square x will happen. So clearly if you replace, basically your y will be replaced by x. So clearly sec square x minus sec square x is equals to 1, 0 is equals to 1. Not possible. Hence it is not reflexive. If I check the option now, then it will be like reflexive is not there, reflexive is not there. If I put, sorry, this is tan square, oops, sec square x minus tan square square x, right? Minus tan square x, yes, is equals to 1. And you know what? Sec square x minus tan square is actually 1. So this is a true statement. So what does that mean? That your relation though is definitely reflexive. Now you know what? If you are smart enough, then option 1 is also agreeing that your relation is reflexive. Option 2, equivalence relation, what? Reflexive, symmetric, transitive, right? So option 2 is also telling you that yes, reflexive is there. Option 3 is also supporting reflexivity. Option 4, see, all 4 options are telling you that the relation is reflexive only. So no need to check this, no need to waste your time on reflexive if you are alert, if you are observant then. Okay, now let's talk about symmetric. What is the condition of symmetric? Symmetricity says that if x comma y is sitting inside your R, that means y comma x should sit inside your R. Now if x comma y, you are telling that if condition is there, that means that we know that sec square x minus tan square y is equals to 1. What does that mean? Sec square x is equals to sec square y. Okay, sec square x is equals to sec square y. So clearly x will be equal to what? Sec square or cos square x is equals to cos square y. So cos x is equals to plus minus cos y. Correct? This is the implication. Now, if you have to check whether y comma x will sit inside your relation. So you have to check whether sec square y minus tan square x is this equals to 1. We need to check the validity. Okay, so this is sec square y is equals to what? 1 plus tan square is what? Sec square x. So can you see again same kind of relation we are getting? So yes, it is symmetric as well, my dear students. Symmetric. Okay, so reflexive and symmetric is there. Now transitive. So we need to check if x comma y belongs to R and y comma x belongs to R. Sorry, y comma z. If these two conditions are true, we need to check whether x comma z belongs to R or not. Okay. So here understand. See, this is actually 1 plus sec square x is equals to sec square y. So this says sec square x is equals to sec square y. Now sec square y is equals to sec square z. Don't you think that sec square x and sec square z are also equal? Okay. So over here, it will be an equivalence relation, my dear students. Okay, don't you think it is not very difficult question? The first question, okay. So in such questions, what you need to figure out is whether your relation is equivalence or not. Basically, reflexive, it will revolve around reflexive, symmetric and transitive. Clear? Okay. Shall we move on to the next problem? By the way, again, today's session also carries a lot of ninja technique. Okay. So, yes. All right. So now this is one such question and yes. One more question based on similar topic, which is again you have to check whether the given condition will fulfill reflexivity, symmetricity and transitivity. Okay, what is this question is saying? A be a set of all functions, R be a relation on set A such that R is equals to this. So can you see now that f comma g, right, f comma g. So this f comma g will sit inside your relation. That means two functions f comma g will belong to your relation if 0 value of first function will be equals to 1 value of the second function. This is given. Now again you need to check the reflexivity, my dear students. Okay. So reflexivity, if I check, reflexivity says that both functions should be same. So f comma f we need to check is sitting inside your relation or not. Basically you have to replace g by f. Okay. So f of 0 here should be equals to f of 1. If this is true, then this will be true. F of 0 and f of 1, are they equal? So ma'am, f of 0 and f of 1 are not equal. In fact, yes. F of 0 and g of 1 is equal. One more condition, and. These two conditions. F of 1 is equals to G of 0. Okay. So we need to check F of 0 should be equals to F of 1, and again F of 1 should be equals to F of 0. Basically, if you replace G by F now, both conditions should be the same condition. Is this true? Not true. Is this true? Not true. Both are not true. Both are same condition. So this is not reflexive. First thing is very clear that this is not reflexive. So not reflexive. Okay, neither reflexive, reflexive. So wrong, and neither reflexive. I think option C is eliminated. Now let's check for symmetricity, everybody. If I check for symmetricity, then what does that mean? That if F comma G belongs to R, that means F of 0 and G of 1 are equal, and F of 1 and G of 0 are equal. Then we need to check whether G comma F belongs to R or not. So we need to check whether G, now F and G will get interchanged. So G of 0 and F of 1 should be equal, and over here, can you see G of 1 and F of 0 should be equal. G of 1 and F of 0 should be equal. Okay. So clearly this is true. Why? Because can you see the second is matching with first. G of 0, F of 1 equal true, and this is also becoming true. Because if this is true, then this is also true. So yes, it is symmetric. Symmetric but not reflexive. So symmetric is there. So that means again option 4 is cancelled, because they are saying not symmetric. Now transitivity will change the whole game. Tell me whether it is transitive or not. So F comma G belongs to R and G comma H belongs to R. That means F comma H should belong to R. Okay, now tell me. F comma G, if at all they belong to R, F of 0, G of 1. And G of 0 is equals to F of 1, correct? G comma H belongs to R. What does that mean? So G of 0 is equals to H of 1, and H of 0 is equals to G of 1. Now if F comma H belongs to R, that means F of 0 is equals to H of 1 and H of 0 is equals to F of 1, right? So we need to just prove it. Okay, so F of 0, ma'am. F of 0 is equals to G of 1, correct? And G of 1 is equals to H of 0. So actually F of 0 and H of 0 are equal. So this is wrong. Using this statement, this is what I am getting, not this. So clearly it is non-transitive as well, right? So non-transitive. So symmetric and neither reflexive nor transitive. Clear, everybody? Okay. So this is how basically you have to identify whether the relation is symmetric, reflexive or transitive or not. Okay. I hope now you know what is symmetric, what is reflexive. Okay. Now one question we'll be doing, okay, which is this. Now see, I told you 3 category question. So either they will ask you whether it is equivalence relation or not, basically symmetric, reflexive, transitive, or they will ask you number of relations. How many relations are possible? Again, JEE Main PYQ. So learn the technique, okay? The number of non-empty equivalence relation that you need to figure out on the set this. So I am talking about R1. R1 is a relation, okay? Now it will have 1, 1, 2, 2, 3, 3. So that it will become reflexive. Okay? This is a reflexive relation. Correct? Okay? Now this is a reflexive relation. So that's it. It is a symmetric as well. Tell me, reflexive is there? Symmetric is there. Because you know what symmetric means? If x comma y is there, y comma x should be there. If not, then it's fine. I think this is having no issue with symmetric, and transitivity is also on check. Okay. So one such relation has been observed. Now R2. Okay. So R2 over here. R2 will be again 1, 1, 2, 2, 3, 3 will be there. Now let's add one more ordered pair. Let's add 1, 2. So you need to add 2, 1 as well. So this is what? Reflexive, symmetric and transitive. Okay. R3 will have the same pattern, but this time rather than 1, 2, I'll be adding 1, 3 and 3, 1. And R4 will have same pattern, but this time I will be giving 2, 3 and 3, 2. Okay. All right. Now what about R5? In R5 again 1, 1, 2, 2, 3, 3 though should be added. Okay. And now 1, 2 and 2, 3 if I am adding. Okay. So now 1, 2, 2, 3, two ordered pair. Right now, see, I have introduced one only here, and because of symmetricity constraint, I need to add one more, and that's it. I will have to stop it over here. Right now, 1, 2 and 2, 3 I have added. So to make it transitive, 1, 3 also should be needed. And now to make it symmetric, I need to add 2, 1, 3, 2 and 3, 1 as well. So can you see all possible ordered pairs are there in relation number 5. So that means we are at dead end, because all possible ordered pair I have put it in relation number 5. So only 5 ordered pairs will be there. No more ordered pairs I'll be able to create. Okay. Yes. All right. So this is how it is. Okay. Now one more question on your screen. Now this time they are talking about minimum number of ordered pairs. Different category question. This time they are talking about minimum number of ordered pairs. So let's solve it. R is equals to 1, 2, 2, 3, 3, 3. Okay. So this is already added in a relation. Okay. Now they want to add minimum number of elements so that it becomes equivalence. First of all, equivalence means symmetric should be there. To make it symmetric, I need to add 1, 1 and 2, 2. Okay. Let me tell you that 3, 3 was already there. Okay. 3, 3 was already there. I need to add 2. Okay. Now one more thing, because 1, 2 is already there. No? See, 1, 2 is already there. So 1, 2 if at all green. Already there with green. Let's write already there with green. So 1, 2 is already there. So for that I need to add 2, 1. Right? Then 2, 3 is already there. So 3, 2 should be added to make it symmetric, because I have to make it equivalence. And now 3, 3 was already there, so I have written it down. So this is how this relation is reflexive plus symmetric. Now transitive. Ma'am, 1, 2, 2, 3 is there. So there is 1, 3. So 1, 3 you need to add. To counter it, 3, 1 also should be there. Okay, because symmetricity, this particular is very important. Now count the number of terms. So this 1, 2 and this was already there, this was already there. 3, 4 and 5. 5 ordered pairs. 1, 1, 2, 2. So 1, 2, 2, 1, 2, 3, 3, 2. 1, 3, 3, 1. 1, 2, 3. Am I missing out on anything? Okay, sorry. Where is 4, 4, my dear students? 4 is also there. Oops, I forgot. 4, 4 is also added. Okay. So if 4, 4 is also added, there is no 4 over here. So now it is going to be what? 1, 2, 3, 4, 5 and 6. Tell me. Okay. Hold on. Maybe I missed out on this 4, 4. Okay. So 1, 1, 2, 2, 3, 3 already there. 4, 4. 3 ordered pairs is added. Now 1, 2. So 2, 1 ma'am. And 2, 3. So 3, 2 ma'am. Correct. Now 1, 2, 2, 3. So 1, 3 should be there. And they are counterparts. So that is 1, 2, 2, 3 and 3, 1. Okay. 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 ordered pairs. Is it? 9 everybody? Yes? Yes? Okay? Clear? 2,3 was already there. Sorry. Let me check. 1,1 new, 2,2 new, 4,4 new, 2,1 new, 3,2 new, 1,3 new. Now 1,2 is already there. 2,3 is already there. 3,1 new. So now 1, 2, 3, 4, 5, 6, 7. 7 ordered pairs, 7, 7, 7. Okay, 7. Alright. Yes. Clear? Alrighty. So one student is saying, ma'am, easy, bell number, shortcut, 5 answer. I mean, I'm speechless. 7 is the answer. 5 is not even in the options. Okay? Alright. Okay. Perfect. Now, another question on your screen will ask you about adding the number of ordered pairs. Shall we start? A set is given to you. Okay, this is your A set. And RB a relation in such a way that y is equals to maximum of x comma 1. Correct? So let me just calculate. See, L be the number of elements in R. So let me create R, relation R quickly. Okay, so if I put x is equals to -2, tell me the value of y. So ma'am, -2. So -2 comma 1 will be -2 comma 1 comma. Now if you put -1, so -1 comma 1, what is maximum? Ma'am, 1. If you put 0 over here, 0 comma 1, what is the maximum? So 1. Okay. And 1 comma 1, what is maximum? Y will be 1. If x is 2, okay, if x is 2, y will be also 2, because now the maximum became what? 2. Okay. Alright. Yes, now 3. The moment you put 3, 3 comma 3. I think L over here, let us count. Okay. It is going to give you only if y is equal to maximum of x comma 1. Okay. Basically, x will be -2, -1, 0, 1, 2, 3. So 1, 2, 3, 4, 5, 6. L will be 6 kya? Everybody? Yes, L will be 6. Are you calculating with me? L is 6. Now, what is M? Can anybody tell me? M be the minimum or number of elements to be added in it to make it reflexive. Now you want to make it reflexive. To make it reflexive, okay, so reflexive, it should have -2 comma 2. Can we write -2 comma? Yes, -2 comma -2. Then -1 comma -1 should also be there, okay, to make it reflexive. This is reflexive, okay. And if you want 0 comma 0 should also be there. 1 comma 1 is already there, 2 comma 2 already there. So 1, 2, 3. Clearly M is nothing but 3. Now what is N? N means you want to make it symmetric. So now to make R symmetric, this is your R. Let's make it symmetric. So ma'am, I need one more ordered pair to write y comma x. So 1, then it is 2, then it is 3. So N is also 3, my dear students. Not a very difficult question. 6 plus 3, 9, 9 plus 3, 12. Option A is absolutely correct. Okie dokie. Yes? Clear? Alright. Now let's talk about the next thing. See, relations questions are done and dusted. Okay. Are we ready for the functions? Are we ready for the functions? Okay. Ready for the functions, everybody? Yes. Now, there is one category question which every year, almost in every attempt, these the kind of questions are asked. What are these kind of questions? Domain related question. Okay. And I have a ninja style for you, specially for sine inverse and cos inverse category. Okay. That I will tell you later, but right now fx, the domain of this is alpha comma beta, and gx, the domain of this is gamma comma delta. Okay. Gamma comma delta. So now basically what they are talking about is find alpha, beta, gamma, delta. Let's tackle this first and then this. This here I will tell you ninja style, and let's tackle this first. Okay, so log of something is there. Okay, something is there over here. So ma'am, we know that whenever logarithm is there, any expression inside logarithm should be positive. 2 minus 6 log base 27, 2x plus 5 should be greater than 0. Okay, now shift log towards the right hand side. So 2 minus 2 is greater than 6, log of 27, 2x plus 5. Correct? Okay, now this is 2, this is 3. So 1 by 3 and this is greater than log of 27 and this is 2x plus 5. Okay. Alright, now understand. 1 by 3, because I want to create logarithm on both the sides, I am going to multiply log 27 base 27 greater than log of 2x plus 5, 27. Okay. So this is 1 by 3 will go upward, so that log 27 base, both sides can get removed. 27 power 1 by 3 is 3 greater than 2x plus 5. So this is going to give you what? Clearly, this is 2x is less than minus 2. So x is less than minus 1. One more thing, let's not forget from here that this 2x plus 1 should also be greater than 0. So x should be greater than minus 5 by 2. So if I talk about gamma and delta, x is greater than, so gamma is minus 5 by 2 and delta less than 1. So delta is minus 1 because the domain will be what? X belongs to minus 5 by 2 comma minus 1. Clear everybody? Clear everybody? Now let me tell you about the domain of sine inverse and cos inverse type of a function. So whenever it is there, any expression, so suppose this is e, so it is going to be e plus 1 and e minus 1 less than or equals to 0, or direct shortcut. Otherwise the question will be absolutely lengthy. Okay, so 4x plus 5 is that expression e. You add 1, you subtract 1, and then you multiply these two together and make it less than or equals to 0. Otherwise, what you have to do is, you have to make this thing lying between minus 1 to 1, and double dual inequality will come into the picture, and this will make the problem a little bit on a lengthier side, my students. So yes, e plus 1, e minus 1. Can you see? E plus 1, e minus 1 is less than or equals to 0. Now it is very easy. 4 plus 3, 7x minus 2, and in the denominator 3x minus 1. Here also 4x minus 3x, so x and 12. Okay, so 3x minus 7 whole square. Okay, 3x minus 7 whole square. Whole square you can remove, just that x cannot be 7 by 3. X cannot be 1 point something. Okay, now 7x minus 2, x plus 12 if you put, so minus 12 and minus 2 by plus 2 by 7. So it is going to be lying between these two. So can you see, this is your alpha and beta. Alpha and beta. So alpha is minus 12 and beta is what? 2 by 7. Okay. So now just write down this 7 alpha plus 7 beta plus 4 gamma plus 4 delta, everybody. So 7 alpha. 7 alpha is going to be minus 7 to the 40 minus 84. 7 beta is 2 plus 4 gamma. What is gamma, everybody? So 4 gamma is minus 10 and 4 delta is minus 4. Modulus is there. Okay. So minus 84 and minus 14. Can anybody tell me what's the answer? Okay, you can do the calculation from here. All right, everybody. Yes. Now I'll be giving you one question. You do this question. I'll come back in a while because there is someone at my door. Yes. This trick is for sine and cos both. Sine and cos both. We'll apply the same trick. Can you see? Again, here though log of is there. So 2x minus 3, 4x plus 5 should be greater than 0. So x belongs to minus infinity to, see, critical points will be minus 5 by 4 and 3 by 2. So it is going to be minus 5 by 4 union 3 by 2 to infinity. Okay. Alright. Okay. Now what about sine inverse? Ma'am, you told us 4 plus 3x upon 2 minus x plus 1. 4 plus 3x upon 2 minus x minus 1 less than or equals to 0. Correct? Now if you take LCM, what will be there? So 2x plus 2. And over here it will be 4x minus plus 2 less than or equals to 0. So x plus 1, 2x plus 1 less than or equals to 0. Make sure x is not plus 2. So it is minus 1 and minus half. So 2 is already out of the equation. So this is your answer, correct? Minus half to minus 1. Okay. Now understand that 3 by 2 to infinity, so it will not be in picture. Minus infinity to minus 5 by 4. So it is going to be like this. Okay. Hold on. So minus 3. Okay. So it is 4x minus 2. 4x plus 2. Have I done correct? 4 plus 3x. 2 minus x. Okay. So now it will give you minus. Sorry, this is plus 6. Correct? Yes, plus 6. So x plus 3. Okay. X plus 3. Correct? So minus 3 to minus 1 by 2. Yes, that's correct. Okay. Minus 3 to minus 1 by 2. Okay. Minus 3 to minus 1 by 2. And yes, if you take intersection, now see, this is 3 by 2. So 3 by 2 to infinity will lie over here. And this is minus 5 by 4. And this is less. So clearly the answer would be minus 3 to minus 5 by 4. So minus 3 to minus 5 by 4. Alpha and beta, you got it. Okay, this is minus 3. So alpha is minus 3, 9. And this is plus 5. 9 plus 5, everybody, 14 should be the answer. Correct? 3 square is 9. And 4 5s are. Beta is actually minus 5 by 4. Correct? Yes. So 9 minus 5. Yes, 9 minus 5 is 4. Option B is absolutely right. Okay, so this technique will actually cut down the steps also and save your time also, because now the calculator is not even allowed, my dear students. So I think these two questions keep in mind. Usually they give sine inverse and cos inverse if we see a previous couple of questions. Okay, now the next topic on your screen is functional equation. Okay, so again there are 3 category functional equations. 3 category functional equations. Okay, 3 category functional equations. Category number 1, when they give f of x and f of 1 by x together in the same equation, right? F of x and f of 1 by x together in the same equation. Okay, so what you have to do is f of x, you keep it right here, plus 2f of 1 by x is right here, and this is x square plus 5. And in the next step, all you have to do is, this is a set method, replace x by 1 by x. Replace x by 1 by x. So f of 1 by x plus 2f of x is equals to 1 by x square plus 5. Okay, so now what you have to do is eliminate f of 1 by x. How will you do that? So to eliminate f of 1 by x, just multiply it by 2, full equation, and then subtract. So fx minus 4fx minus 3f of x. Okay, 2f of 1 by x, 2f of 1 by x cancel because we are subtracting. This is x square plus 5 minus 1 by, sorry, minus 2 by x square minus 10. Okay, so f of x minus 3 is there, correct? Minus 3, and this is x square minus 2 by x square minus 5. Okay, so minus 3, if you divide it by minus 3, what will you get? Okay, x square, if you divide, so 2 by 3x square, correct, minus 1 by 3x square, and then it is going to be plus 5 by 3. This is what your f of x will look like. Okay, now what they are saying is that g of x also in same manner. Can you see g of x is also given, right? G of x is also given in the same manner. First of all, this. Let's talk about alpha. Alpha will be integration of 1 to 2. Okay, so integration of 1 to 2. So let me tell you that this is, see, 1 to 2. So 2 by 3 x power minus 2 minus x square by 3 plus 5 by 3. Okay, dx. Integration not very difficult job. So this is 2 by 3. This is minus 1 by x. This is minus x cube by 9 plus 5x by 3. Okay, 1 and 2. So if you apply upper and lower limits, you will get the value of alpha. So alpha, if you calculate, it is going to be 11 by 9. Do the calculation. 11 by 9 will be your alpha. Okay, so alpha is right here. 11 by 9. So 9 alpha will be 11 plus beta. How will you calculate beta, my dear students? So for beta, see, 2g of x is equals to x plus 3g of half. Okay. Alright, now put x is equals to half. In fact, you have to put x is equals to half, so that it will be 2g of half minus 3g of half. So it is going to be minus g of half is equals to half. So g of half is minus half. Put minus half over here. So your g of x will be what? X and minus 3 by 2 and upon 2. X by 2 minus 3 by 4. X by 2 minus 3 by 4. Okay. So x by 2 minus 3 by 4, my dear students, is your g of x. Integrate. So it is x square by 4 minus 3x by 4, and this is your beta. If you put the limits, it is going to be 1 to 2. So beta value, if you calculate, is going to be 0. Okay. Can you see this is 4 by 4? So 1 minus 3 by 4. Now if you put 1 over here, so it is going to be 1 minus 3 by 4. So negative 1 minus 3 by 4. So this is coming out as 0. So beta is 0. So answer will be option D. Okay. Basically the integration is the second part, but you have to focus on how to solve f of x and f of 1 by x type of equation. This is the core. Okay. And you know what? In fact, 2 more questions were given of the same kind. Okay. But you know what? Sometimes, you know what? Ninja style also can be done in this question if you want to avoid calculation. Can you see this question again? Fx plus 3 f of 24 by x is given to you, and this is 4x. Again, what you can do over here is again equation solving, elimination, but focus on f of 3 plus f of 8. They want f of 3 and f of 8. How will you get f of 3 and f of 8? Put x is equals to 8. So it is going to be f of 8 plus 3 times, can you see if you put 8, 3 times f of 3, and this is 4 8s are 32. Okay. Now next time what you can do is you can put x is equals to 8. You have already put. So this time put x is equals to 3. So ma'am, f of 3 plus 3 times f of, if you put 3 it will be 8. 4 3s are 12. Can you see? F of 3 and f of 8. Two equations, two unknown. You can solve it by elimination method. Okay, what will you do? Just multiply the first equation with 3. Or multiply the second equation with 3. Yes, much better. Now subtract. Okay, so it is going to give you what? 3 3s are 9. So 7 f of 8. Okay, and this is 36 minus 32 is 4. So f of 8 is 4 by 7. Okay, because you know what? 3 3s are 9 minus 1. Sorry, this is not 7. This is 3 3s are 9 minus 1, 8. So f of 8 is 1 by 2. Correct? Okay. F of 8, if it is 1 by 2, then you can calculate f of 3 as well. Yes, f of 8 is half. Is it correct? Hold on, let me check. If you multiply it by 3, so this is 3 f of 3 cancel, and 3 3s are 9 minus 1, 8, 8 f of 8, this is 36. Okay, f of 8 is half. You put half. So 3 f of 3 is equals to 32 minus half. Okay, so this is what? 60. So 32 minus half. Let it be 32 minus half, and this is f of 8 is half. If this is 3 f of 3, correct? So 63 by 2 is 3 f of 3. 3 ones are 3, 2s are 6, 21 by 2. F of 3 is 21 by 2. Okay, so 21 by 2 plus 1 by 2 is 11. Option A, absolutely right. Okay, this is ninja style. Okay, but for specific details it might work. Okay, so again, one more question was found in JEE Main 2025 of this category, where you have to replace x by 1 by x and eventually solve for fx. Eliminate f of 1 by x, you will get the function, and then whatever they can ask you limit question, they can ask you integration, they can ask you whatever they want. Okay, now the second category is this type of question, my favorite questions. Okay, again, there is a longer method. I will tell you what is the longer method, but I will tell you directly ninja technique. Whenever a function is given in this format and sigma of f of k is given to you, first of all you have to do is just count. Step number 1. You have to count the number of terms. Number of terms. Okay, number of terms. If odd terms are there, right now, can you see 1 to 81 odd terms? All you have to do is, you have to make it even. How will you make it even? Tell me. So, ma'am, 81 odd terms are there. So, if you remove that one term, 80 terms will be there. Okay. So, 80 terms. 80 by 2 you have to do. Okay. Basically, n minus 1 by 2. Right. So, odd terms. Number of terms is what? 81 in here. Okay, so all you have to do is 81 minus 1 by 2, which is going to give you 80 by 2. 80 terms, 80 by 2, which is 40. Now, what you have to do is you have to multiply 40 and multiply. Multiply what? Now, you have to multiply f of 0 plus f of. Okay, let me write. Okay, f of 0. F of 0 plus f of what? So for what? F of what thing? So here, tell me, what will be the first term, ma'am? 1 by 82. What will be the last term, ma'am? 81 by 82. What will you get if you add first and last argument? Ma'am, clearly we are going to get 1. So f of 0 plus f of 1 you have to add. Okay. Alright. So 40 multiply. So 40 will be there. Okay. So 40 multiply this. Because there are odd terms, so you have to add plus sign. And all you have to do is the middle term. What will be the middle? Tell me. So ma'am, 1 and 81. So middle is 41. So if you put 41 over here, clearly it is f of half. So plus f of half, this is your answer. That's it. This is a shortcut. So 40 multiply f of 0. Everybody f of 0. Ma'am, 1 plus 1 upon 1 by root 2. F of 1, everybody, 2 upon 2 plus root 2. And f of half, ma'am, root 2 upon root 2 plus root 2. This is your answer, my dear students. So this is 40 and 1 upon 1 plus root 2. If you take root 2 common, it will be what? Root 2 upon root 2 plus 1. And if you again take, see this is root 2, so this is just 1 by 2. Okay, so the answer would be 40. If you add, what will you get? Cancelled. So 40 plus half will be the answer. So this is 80.5. 80.5 is what? 40.5, which is option D. This is the ninja technique. Okay. Now, do you want to do one more question on ninja technique so that you understand it better? Let me tell you that also. Okay, again a JEE Mains 2025 PYQ fx is given in this format and sigma is here. Okay, first of all, let me just redo this question because right now I feel that this question can be done again. How come, ma'am? Let me see. So, f of x will be what? 2 power x 4 plus 16 whole upon 2 power 2x 2 plus this is 2 power x 4. Okay, and plus 32. So one thing is clear that we can remove 2 from numerator and denominator. Is it? Yes, 2 can be removed. So yes, ma'am, let's do it. This is what? 2. This is your 8. Okay, this is your 2. This is your 2. This is your 16. So f of x is what? Again, if you take 2 out, 2 power x plus 4, ma'am. 2 power x plus 4 whole upon, can you see this is 2 power x whole square plus, what is this? 2 into 2 power x, and what is this? This is 4 square. Sorry, this is 2 power 4. 2 power 4 is 16. 16, so this will be 8 if you calculate. If now this is what? 2 and 4, and this is 4 ka square. Okay, so can you see a square is getting formed? So we are simplifying fx, that's it. So ma'am, 2 power x plus 4, and this is 2 power x plus 4 whole square. Okay, so this is getting cancelled out. So now simplified version of your fx is this. Now this is your fx. Okay, I have done nothing, but this was a complicated version. I have simplified it. So now this question looks like the previous question at least. Now tell me how many terms are there? So ma'am, 1 to 59, the total 60 terms are there. So right now 1 to 59, sorry, 59 terms are there. 59 terms, correct? So ma'am, 59 minus 1. 59 minus 1 by 2. Okay. So it is going to give you 58 by 2. 58 by 2 will be what? 29? Yes, 29. So now 29 you have to multiply. See, I am calculating this. Okay. With f of 0 plus f of what? F of 0 plus f of what? So for that, see 1 by 15 and 59 by 15. Add first and last. Tell me what will happen. Ma'am, 1 plus 59 is 60. 60 by 15 is 4. So basically you have to write f of 4. Okay. Now what will be the middle term? Tell me middle term. So ma'am, middle term will be 30 by 15. 30 will be the middle, right? So 30 by 15 will have no pair. So ma'am, 30 by 15. So all you have to do is, because see, again, so f of 30 by 15 is ma'am f of 2. So that's it. This will be your answer. So 29, f of 0, everybody, f of 0. So ma'am, 2 by 5. F of 4 everybody, so 2 by, if you put 4 over here, so it will be 2 power 4. 16 plus 4, 20. Yes. And plus f of 2 everybody, so 2 upon, this is 4 plus 4. So 2 by 8. This will be your answer. So 29 multiply, now this is 1, this is 10, correct? So this is 4 plus 1, 5 by 10 plus 2 by 8 is 1 by 4. Okay. So 1 to 59, 59 terms. Total 60, 60 minus 1, 59, correct. So the answer would be, let me tell you. Okay, so this is 1 by 2 and this is 29 by 2, correct? Let me check, what's the answer? 29 into, absolutely, this is absolutely correct. Please do not forget to multiply 8 in the whole situation. If you multiply 8, so this will be 4 multiply 29 plus 2. This will be your answer. So 9 4s are 36, 3 carry, 4 2s are 8, 9 10 11, 116 plus 2, 118. Option B will be the final answer. This is how functional equation will work. Okay. Now the last category of functional equation is this. Okay. So please read it carefully, and the most important one I will highlight. Okay, most important one I will highlight, and which is going to give you this: f of x plus f of 1 by x is equals to fx plus f of 1 by x. Okay, so if at all this kind of equation is visible to you, then what to do? Then there are only two polynomials which will satisfy this condition: 1 plus minus x power n, and JEE Mains 2025 PYQ, if you can see, same equation. So the moment we see this, we realize, okay ma'am, my fx is equals to 1 plus minus x power n. This is a polynomial. Okay, of degree 2. So clearly that square will be there. Okay. And also one more thing, because the range over here or the codomain set is negative, that means f of x will be 1 minus x square. Okay, 1 minus x square. So I think right here you have your f of x, and now they are telling you that f of k is equals to minus 2k. So f of k is equals to 1 minus k square is equals to minus 2k. Shift everything towards the right hand side. K square minus 2k minus 1 is equals to 0. So sum of squares of, now they are talking about k1 square plus k2 square. So this will be equals to k1 plus k2 whole square minus 2k1 k2, right? Alpha square plus beta square. So k1 sum of roots 4 square minus, or 4, just 4. So this is 4 plus 2. So the answer will be very easy, which is 6, only if you know the functional equation chart. So that chart is very much compulsory, my dear students. And on this note, we have finished this particular chapter. Okay, and yes, so many questions in just 1 hour we have done. So make sure that you maintain a copy in which you can write that what are the questions which will be important for your JEE Main 2026. Okay, this is me, your Ninja Ma'am. Day 5 done and dusted. All 5 days. Please, if you have not watched it, go back and watch. Okay. All right. Yes, Rohit, you are late, and rest of the people, recordings are available. Just go and check. One last time, I am going to tell you that if you haven't liked the session, Sigma High Weightage Crash Course, that is going to get launched on tomorrow, 6 o'clock. Can you see? Okay, make sure that you like it. And this is going to be a game changer, complete game changer in your JEE main preparation. Okay, because the strongest team of South India is right